Greetings and welcome to Chemistry in the AM, already in progress. If you're just joining us, once again, this is Chemistry in the AM. I'm your host, Joel Stout. Okay, we just talked about things, we saw some videos, we talked about food we've tasted before, so on. So you're going to fill in some things about acids and bases that we already know. The taste, we said, was sour. Bases tend to be bitter. The feel of solution. Now, vinegar, if you had it on your hands, it doesn't feel much different than water. That's a distraction at the door. What do we know about bases? And thinking that they're soaps, slippery. Yeah, we know that soaps are bases, slippery. Now, a stronger base, bleach, I don't recommend spilling it on your hands because you need to wash. But if you spill bleach, it's very slippery. So if you actually spilt a jug of bleach down in your laundry room or something where you might have bleach, your floor will be really slippery. Plus, it's going to damage your floor. You know what bleach does to clothes and stuff like this if you have too much, right? Oh, yeah. It takes out all the color, and then after a month of washing it and stuff, it probably disintegrates. So it's dangerous. So, yeah. Your hand shouldn't feel like rubber. That's sticky usually. I don't see why you get bleach in your hands very often. Okay? Okay. So the pH. I'm going to say less than 7. pH for acids, less than 7. Greater than sign, 7. I'm going to just put something in here, neutral. Keep that in mind. Now, in the video, it said something about conductivity, the ability to conduct electricity. Because if you have an acidic solution or a basic solution, you're going to have ions floating around. They're charged, anions, cations, right? It allows it. It's pure water doesn't conduct electricity very well at all. But bases and acids both conduct electricity. I'm going to write that across. And that's from grade 10, but you probably didn't talk much about that. Now, here's where I'm going to pause the video, and we're going to play around a little bit with something called litmus paper. We got blue litmus paper, red litmus paper. Then we're going to talk about phenolphthalein. It's a indicator. It indicates something that's acidic or basic. It's the one I use because I'm colorblind. Because it's either clear and colorless, or it's reddish or pinkish. I think that's what people tell me. Okay. And we'll play around with some metals. So I'm going to pause the video. You won't be able to see this on video. So with the litmus paper, the red stayed red. The base, red, turned blue. What you want to remember for this then as a summary is R B B for base. Red to blue is base. RBB. Then we'll test with the blue strips. So when we did the litmus, our acid blue turned red. As a summary, I like to say B, blue, red means it's an acid. You remember BRA, blue to red is acid. Okay. Then you know the opposite, red to blue is base. Right? Just remember broth. Blue red acid. If you only do one test, and I dip something and I dip a blue sheet and there's no change, what do you know about it? Blue, right. You can't just say it's an acid. You have to do a second test to confirm it. So, we're just saying, blue stays blue. But the same would be true with water. So you can't just say blue, I tested blue litmus paper, stays blue, is a base? No. Could be blue. So you need a second test to confirm that it's a base or it is. And vice versa with the acid. If it's red, test it, it's red. It could be water. All you know, when you have something that's no change, so I do a test, and I've got red and it stays red. Sorry. So if I test something and it's blue, stays blue, I don't really, so all I do know something for sure though, it's not an acid. You can state that with certain. You just say not an acid. You don't know if it's neutral or if it's, right? Okay. Then we're going to test with this phenolphthalein stuff. I'll pause the video thing. So phenolphthalein, there's other indicators that have yellows, and actually you guys have played around with that. Remember the demonstration where I think that we went from yellow, greenish, blue, and stuff like this? Because I can't tell where yellow and green, blue change very well. I just use phenolphthalein. It's on or off. So colorless. You can say clear, but clear doesn't tell me anything. They're both clear. Pink and clear. Colorless and clear. So clear and colorless. So I just say colorless, right? People tend to think that when they say clear, they mean colorless, but it doesn't necessarily. Colorless pink solution? Colorless opaque or translucent solution? No. Copper, to you, I'm going to put an X in. Nothing. X means doesn't work. This makes sense. This is a good choice, and this is why copper is used for plumbing. Because you don't want something acidic eating away at your plumbing, right? Copper doesn't corrode very well. Very slow and very little. So this is good in normal conditions. So zinc, we'll write this one down. Zinc, a yes for acids. Zinc, a no for bases, right? Okay, so we're using check mark or X, yes or no. So we observed through video in slow-mo. Aluminum doesn't react with acids, which is a good thing while your pot cans are made out of aluminum. It does react with bases. Okay. So tin, SN is the symbol for tin, by the way. Stan on this. Okay. So tin will react with acids. Tin, SN, will not react with base. What's that? What was that? What did you have? What did you have? Nothing for either? What did you have for bases? this year, I don't see any evidence of it, but it's a pretty weak acid. I bet you I use a really weak acid. Okay, magnesium reacts with metals, and it does not with bases. Now, I'm going to just run through the last ones. Like carbonate, baking soda. Baking soda and vinegar, you guys know this one? Yes, right? Those are acids. Yes, as it reacts. Reaction with carbonates. Carbonates are on the basic side, so they don't react. Don't. Ammonium chloride, I'm not going to do it here. And yeah. Okay, that's enough. We will talk about this tomorrow. Get those assignments in.